Hi, good morning to one and all. In previous class we discussed one problem regarding the calculation of torque, power and angle of twist. Okay. Next, coming to second problem. Determine the diameter of solid shaft which will transmit 400 kilowatts power at 280 rpm. The angle of twist must not exceed 1 degree per meter length and maximum torsional shear stress is limited to 40 Newton per millimeter square. Here they given that assume G is equals to 84 kilonewton per millimeter square. First, note down given data, that is they given that power value 400 kilowatts and convert into Newton millimeter per second, because they given G value in terms of Newton per millimeter square. Next, speed value n is equals to 280 rpm. Next, angle of twist must not exceed 1 degree per meter length. Okay, theta value is nothing but 1 degree. You need to convert degree into radians, so that by multiplying pi by 180 we can convert degrees into radians, and maximum torsional shear stress is to be limited 40 Newton per millimeter square. Okay, maximum shear stress is given as 40 Newton per millimeter square. And finally, G value, modulus of rigidity, as for 84 kilonewton per millimeter square. Can convert kilonewtons into newtons, that is 84 into 10 cube Newton per millimeter square. Okay. From this, first we note down the required data. After that is, we need to find out the diameter of solid shaft. Okay, we can find out diameter from the torsional equation, that is T by J equals to Q by R is equals to G theta by L. Okay, from first two terms of torsional equation we know that is T by J equals to QS by R. Okay, or we can be written as D by 2. Okay, from that equation we can calculate D value. Okay, first, for substituting the value of T, J and QS by R, we know that QS and torque value we can find out by using power equation. Okay, next J value, polar moment of inertia. Okay, we can write formula in terms of diameter. Okay, finally we can calculate the diameter of the shaft. So that first, note down the power equation, that is P is equals to 2 pi nt by 60. Okay, next, note down the value of power, that is 400 into 10 power 6, that equals to 2 pi, n value is 280 and T is we don't know by 60. Okay, from this, by simplifying this equation we can calculate the torque as 13.64185 into 10 power 6 Newton millimeter. Okay, it is the value of torque. Okay, by substituting the torque value in torsional equation we will get D value, that is diameter of solid shaft. From the consideration of maximum shear stress, T by J equals to QS by R, because the maximum stress will develop at the outermost layer of the shaft. Okay, substitute T value, that is 13.64185 into 10 power 6. J is pi by 32 d power 4. It is the polar moment of inertia for circular section, solid circular section. Next, QS they given as 40 and R value you can convert radius of the shaft in terms of diameter, so that R can be written as D by 2. Okay, by simplifying this equation we get the value of D is 120.206 millimeters. Okay, next, from the consideration of maximum angle of twist, you know that by equating first and last term in the torsional equation, we can also calculate the D value. Okay, T by j equals to g theta by L. We know that theta they given as 1 degree. We need to convert 1 degree into radians. And length of the shaft is they given as 1 meter. So that substitute the L value and theta and g value in the above equation. We will get the diameter is 98.67. So that minimum diameter of the shaft to be used, that is 120.206. Okay, next, coming to next problem. A hollow circular shaft 20 mm thickness, it transmits 294 kilowatts at 200 rpm. Determine the diameter of the shaft if shear strain due to the torsion is not to exceed, that is 8.6 into 10 power minus 4. Take modulus of rigidity as 80 giganewton per meter square. Okay, here up to now we solved two problems. In the two problems we solved based on the solid shaft, but in this case they given the shaft as hollow. Okay, for hollow shaft 20 mm thickness, they given thickness of the shaft, but they are not given internal and external diameter. We need to calculate the internal and as well as external diameter. Okay, the hollow shaft is transmits a power from one point to another point, that is the power value is 294 kilowatts. Okay, at 200 rpm, power is 294 kilowatts and speed is 200 rpm. From these two values we can calculate torque value. Next, determine the diameters of the shaft. Diameter of the shaft is hollow means we need to calculate internal diameter and external diameter. Here d1 is the external diameter and d2 is the internal diameter. Okay, they given one more data, that is if shear strain due to the torsion is not to exceed 8.6 into 10 power minus 4. Okay, already we know shear strain means modulus of rigidity is equals to shear stress by shear strain. Okay, from this by using this data we can calculate the value of shear stress. They given also modulus of rigidity as 80 giganewton per meter square. By using these shear strain and g value, we can calculate the QS, that is shear stress developed in the shaft due to the power transmission applied torque. Okay, first of all let us consider d1 is equals to external diameter of the hollow shaft and d2 is the internal diameter of the hollow shaft in millimeters. Okay, next they given thickness as thickness of the shaft. Okay, that is 20 millimeters. From the thickness we can write d1 minus d2 is equals to 2 times of thickness. Okay, the given thickness as 20 mm. So that 20 into 2, that equals to 40 mm. From this equation we can written as d2 in terms of d1, that is d1 minus 40 mm. Okay, next, first note down the given data. Shear strain due to the torsion developed, that is E suffix S is equals to 8.6 into 10 power minus 4. For strain value there is no units. Okay, next they given one more data, that is G value 80 into 10 power minus 3 Newton per millimeter square. Okay, from these two values we can calculate the shear stress. Next, power transmitted, that is 294 kilowatts. We can convert 294 kilowatts in terms of Newton millimeter per second. Okay, 1 kilo means 10 cube and 1 meter means 10 cube mm. So that by multiplying 294 into 10 power 6 we can convert kilowatts into Newton millimeter per second. Okay, next, coming to last one, that is speed of the shaft. It will rotate 200 revolutions per minute. Okay, next, note on the required data. We need to calculate the internal and external diameter of the hollow shaft. Okay, first of all by using power equation, power equals to 2 pi n2 by 60. The given power value and speed, by substituting all these values in the power equation we will get the torque, that is 14.037 into 10 power 6 Newton millimeter. Okay, by substituting the T value in the torsional equation, that is T by J equals to QS by R. Okay, T is 14.037 into 10 power 6 Newton millimeter, and J is, can we write formula, that is pi by 32 into d1 power 4 minus d2 power 4. Already we discussed the formula for polar moment of inertia for hollow circular section. Okay, substitute the formula of polar moment of inertia. Next, R is nothing but radius of the shaft, that is maximum radius from the center of the axis, so that the maximum value is d1, so that R can be written as d1 by 2. Okay, by simplifying this equation we get the value of Qs in terms of d1. Okay, we know that from the shear strain, by considering the shear strain, we'll get the value of Qs is 68.8 Newton per millimeter square. Okay, by substituting this value in this equation, we'll get the value of d1 is 1.039 into 10 power 6 millimeters. Okay, it can be converted as, okay, this equation is equals to 1.039 into 10 power 6. By simplifying this equation, trial and error method, we'll get the value of d1, that is external diameter, is 108 mm. Okay, by substituting d1 value in equation d2, we'll get the value of d2 is 68. Okay, the difference between d1 and d2 is 40. Okay, like this we can calculate the diameters of hollow shaft. Okay, next, coming to next problem. During test on a sample of steel bar 25 mm diameter, okay, it is found that the pull of 60 Newton produces an extension of 0.1164 millimeters on a length of 200 mm. Okay, they conducted one test on steel bar having diameter 25 mm and upper load is 60 kilonewton and length is 200 millimeters. Due to the application of load, it extends, okay, with 0.1164 millimeters, and a torque of 220 Newton meter produces an angular twist of 1 degree on a length of 250 mm. Okay, find the Poisson's ratio of this steel. Okay, here we know that from the relation between E and C, okay, by substituting the values, by calculating the E and C value G, okay, we'll get the Poisson's ratio. First of all, note down the given data. Diameter is 25 mm. Next, load, upper load is 60 kilonewton. We can convert into kilonewton into newton, that is 60 into 10 cube. Extension, here they mentioned delta. We can also written as delta L, that is 0.1164 on a length, that is L is equals to 200 mm. Okay, from this data we can calculate Young's modulus. We know the formula. Young's modulus is equals to stress by strain. Okay, stress means P by A, load by area, and strain means change length by original length. By simplifying that equation, we will get the formula for Young's modulus is PL by A into delta L. Okay, by substituting all these values, we will get the value of Young's modulus is 210019 Newton per millimeter square. It is the value of Young's modulus. Okay, next, from torsion test data, the torque given as 220 Newton meter and twist over a length of 250 mm is 1 degree. We know that formula for T by J is equals to Qs by R is equals to G theta by L. From that equation, we consider first and last terms in that equation, that is T by J equals to G theta by L. Here we know that L value and theta value and torque and J. J means pi by 32 to the power 4. Okay, by substituting all these values, we will get the value of G as 82,172.3 Newton per millimeter square. Okay, from the by using relation between E and G, we know that E is equals to 2G into 1 plus mu. Okay, we know that Young's modulus and G value. By substituting E and G in the above equation, we will get the value of Poisson's ratio, that is 0.28. Okay, like this we can calculate the value of Poisson's ratio. Next, coming to one more problem. A shaft is required to transmit 300 kilowatts power at 220 rpm. Okay, a shaft is required to transmit 300, the given power value and speed value. From this we can calculate the torque. Next, the maximum torque may be 1 times the mean torque. Okay, by using the power and speed we can calculate the torque, that is mean torque. By multiplying with 1.5 we will get the maximum torque. Okay, next, the shear stress in the shaft should not exceed the given maximum shear stress induced in the shaft is 45. Okay, beyond the limit we cannot, the shaft is not bearable, so that the maximum shear stress developed in the shaft is 45 Newton per millimeter square and theta value is 1 degree per meter length. Okay, now we need to calculate determine the diameter required if the shaft is solid and the shaft is hollow with external diameter twice the internal diameter. Okay, take modulus of rigidity. First we need to find out the diameter of the shaft when the shaft is solid. Okay, on the power equation we can calculate the T value, that is 13.0218 into 10 power 6 Newton millimeter. Okay, by multiplying that mean torque into 1.5 we will get the maximum torque as 19.53265 into 10 power 6 Newton millimeter. It is the maximum torque developed in the shaft. Okay, next, for finding the diameter of the shaft, first consider the solid shaft. For solid shaft, the polar moment of inertia is J is equals to pi by 32 d power 4, where d is the diameter of the shaft. From consideration of shear stress, T by J equals to Q by R. R can be written as in terms of diameter, that is d by 2. We don't know radius, so that it can be written as in terms of d. Okay, here J is pi by 32 d power 4. By simplifying this equation we will get the value of torque, that is pi by 16 d cube into QS. Okay, designing for maximum torque, we have the value of torque is 19.5325. Okay, by substituting the value in the above equation we get the diameter of the shaft is 130.27 millimeters. Okay, next, from consideration of angle of twist, T max by J is equals to G theta by L. Okay, up to now we calculated diameter based on the shear stress. Now we are going to calculating the stress based on the angle of twist. Therefore, T max by J is equals to G theta by L. Okay, T max we know and G value they given and theta length. Okay, substituting all these values we'll get the diameter as 109.26. Use a minimum of 130.27 mm as diameter. Okay, now we need to calculate the for diameter for hollow shaft. Okay, where d1 is the outer diameter and d2 is the inner diameter. Okay, they given one condition, d2 is equals to half of the d1, that means internal diameter is equals to half of the diameter of d1. Okay, therefore from this condition we can calculate the polar moment of inertia, that is J equals to pi by 32 into d1 power 4 minus 0.5 times of d1 power 4. By simplifying this equation we will get the value of J is 0.092039 d1 power 4. Okay, by considering the maximum shear stress condition, T max by J is equals to Qs by R, or you can written as d1 by 2. Okay, substitute T max, J and Qs. Okay, we will get the value of d1 is 133.1 mm. Okay, Next, from consideration of angle of twist, T max T by J equals to G theta by L. Okay, T max is 19.5325 into 10 power 6 and J is 0.09203 d1 power 4 and G value is 18 into 10 power cube and theta is 1 degree. That is, we can be multiplying radians into, we can convert radians into degree. That is 5 by 180 into 1 by L. Length of the shaft is 1 degree per meter length. So that 1 meter is equals to 10,000 mm. By simplifying this equation, we will get the value of D is 111.03 mm. Okay, minimum dimensions to be used that are, therefore D1 is 133.1 mm and D2 is 0.5 D1. So that D2 is equals to 66.5. Okay. In next class, we will discuss some more problems. Okay. Thanks for 2 నిమిషాలు వచ్చింది.